Hello, good morning, good afternoon, and good evening. On behalf of PioPetro and Millet Research Hub, I'd like to welcome you all in our fourth session of the summer internship program. My name is Mayar Tara, a senior gas and petrochemicals engineering student, SPE Egypt Young Professionals member, and I'll be your moderator for today. So, before we start, please keep the chat box professional and ethical. And don't forget to drop your questions in the Q&A section below. So without further ado, let us welcome Dr. Rami Aloush. Dr. Rami Aloush is the technical product owner of upstream data at S&P Global Commodity Insights in the United States. He brings extensive experience in reservoir engineering, digitalization, research, and data science to his role. Prior to joining S&P Global, Dr. Aloush was a research assistant at the University of Wyoming Center of Innovation for Flow through Porous Media, where he earned his PhD and was awarded his patent for research digitalization and automation. Dr. Rami research focused on fluid phase behavior at the nanoscale in unconventional reservoirs and the application of machine learning and artificial intelligence within the oil and gas industry. Dr. Aloush also holds a master's degree from King Fahd University of Petroleum and Minerals in Saudi Arabia. During this time, he served as a consultant at Saudi Aramco's Reservoir Characterization Division and as a teaching assistant at King Fahd's College of Petroleum Engineering and Geosciences. Dr. Rami's earlier career includes roles as a consultant assistant at the Egyptian Petroleum Consultancy Company and the teaching assistant at the American University of Cairo. Following his Bachelor of Science degree in Petroleum Engineering from Suez University in Egypt, a recognized expert in his field, Dr. Aloush holds machine learning engineer and data analyst certification from leading companies like Amazon, Microsoft, and Google. He has an impressive portfolio of projects and publications addressing energy-related challenges through machine learning and data analysis techniques. Thank you so much, Dr. Rami, for coming today, and the mic is yours.
Thank you. Thank you so much, Maya. Is the sound clear?
Thank you. Yeah.
Very good. Alrighty. Hello, everyone. Again, thank you for the introduction. My name is Rami, and I will be chatting with you about machine learning. I actually was expecting a much smaller class. So usually, my lectures are a little bit more hands-on and practical, and we still do that. I'll just try maybe to go a little bit slower, and maybe with the next session you could be ready with your computer, with your laptop, if you can, and maybe try to follow through or really get this feel of hands-on. My belief when it comes to machine learning is usually is that it cannot just be taught. Like, you can have hundreds or thousands of lectures and looking at slides, but it's about getting your hands dirty, as we call it, like getting hands-on experience is what really matters, what makes a real difference. And that's why I encourage you to do. And what I'm sharing with this course is not a typical machine learning, like we go through the definitions and the stuff. No, that's why even I changed the course title here. I think it was shared with you like as machine learning applications in oil and gas industry. And this can be like one slide. I already have it, but it turned out to be just one slide. We can keep talking about how and where you can use machine learning in the oil and gas industry. But again, I'm trying this with you, this course. I thought it would be much better if we can have it more practical, like really do something with machine learning in the oil and gas industry, and maybe earn some money while doing so. You'll understand later. We will be exploring a public challenge, so it will be less slides and more hands-on coding, looking at the data, exploring the data, and so on. So, and this is what we should be doing in this regard. We should be trying and getting stuff done rather than really learning about what could be done. And this is what we'll try to do this course. Again, with the current setup, with the webinar, it will not be as interactive as I was planning to. But again, we let's plan to make it work. Let's utilize the chat. Like if it's okay with you, Mayar, we might have like a little bit more frequent stops with the questions rather than at the end, if that works with your style. And see how it goes. Like we will be dynamic, and this actually the main word I have when it comes to the next slide. It's dynamic. So for me, the course is all about getting benefit to you. Like you learn something new, and I believe this is through a little bit more practical approach, because you can search, you can ask ChatGPT, what can I do with machine learning in the oil and gas industry, and the list is very large. Like there is so many things you can find the titles about, but what can be a practical way of approaching this is what I'm looking to share with you today. So as a general approach to this course, we'll have a very generic overview of ML or machine learning, which I assume you would already have some experience with, already aware of. And then again, this one slide that I told you about, which is how can utilize the oil and gas utilize the machine learning in the oil and gas industry. And again, based on your feedback today, this will determine the rest of the course of this. We still have 3 sessions to go. So based on your feedback from today, we might pivot to really be it more a standard, like we can really dive deeper and share some case studies of how machine learning is being utilized in the oil and gas industry rather than my original plan of having the hands-on. So please share your feedback. Maybe like the other strategy, we can pivot. I'm very flexible, so we can pivot if the current course setup will be more beneficial to you, to have maybe like you understand and study how the machine learning is being used in the oil and gas industry rather than being hands-on and trying to do it ourselves. So we cannot do both, unfortunately. Like the time is pretty tight. So we either explore all the ideas and all the ways that ML is being used in this domain, or we pick one example and we work on it, which is my current plan. But again, I'm flexible and we can pivot. And then this hands-on that we'll do today would be through the public challenges. So there are multiple platforms that puts out data challenges, machine learning challenges, some of them very specific to the oil and gas industry, and you get money actually. Like you can win a prize if you solve the challenge, and this is what we will do. We will not solve the challenge, like it has been going for 10 weeks now, but we will go through it, like introduce you to the concept, which I believe is very very valuable, and maybe try to make 1 or 2 submissions together just to show you the process from A to Z. There's still 3 weeks remaining the challenge that I'm planning to work with, so it might be not too late for some of you to get your hands on if we decide to go this route. And then again, like as I said, the hands-on, which is my current plan, and the wrap up. I see a question here from Rida. Which language programs coding should a petroleum engineering learn to help him during his work and to get better chance to be hired? Very good question. The de facto, we will go through this. The de facto, this is Python is the de facto, like the standard, but I have like I have a very I would say very particular opinion that it's not about coding anymore. And like this has changed just last year, right? And if you hear like the CEO of Nvidia, for example, he's like don't learn to code. It's you don't really need that skill. And I wouldn't say I 100% agree with him, but I would say don't make coding is a blocker. Like we can solve the whole, like we can submit a whole challenge, as you will see, without really knowing to code. We will just have ChatGPT or have Google Gemini, which is embedded in Google Colab, and have the code being written for us. Having the knowledge, having the coding, which will be definitely helpful, but it's not. You don't need to spend 3 years learning to code before getting into the machine learning. No, this is no longer the case. You can really get into the coding, get into the machine learning applications, and really have some results available to you much faster than you think. Um, um, I see another question. It's a little bit long, so let's uh, let's defer this a little bit. It will be. I don't want to keep everybody. We'll have a break and then go through the kind of longer questions. So again, let's start with this quick overview about machine learning and the different terminologies that we have these days between machine learning and artificial intelligence, so on. So artificial intelligence, like the general umbrella, right? It's having the computer do something. Basically, that's it. Like you give it a command and it can obey the command. So this is the general uh, umbrella we have. And then we have machine learning, which is very specific. This is where we are at, which you have a specific algorithm that can have performance improvement. And this is the key part, that as a machine learning, you have the machine to learn something. It doesn't know something, and then it becomes knowledgeable of this thing. And then what happens in between is what we call is the training, is to give it data to learn from. So previously, you would have very specific instructions. Please do this and do this and do this. Do this if this is the case. Do this. Otherwise, do that. You have these very specific instructions, and you don't always know what you need the machine to do. So that's where the difference becomes. Like nowadays, you have a very complicated problem. You don't really know what to tell the machine. So the idea is that you keep the machine itself learns. The machine will be the teacher. How? By seeing huge amount of data. So it sees a lot and a lot and a lot of data, amounts of data that human brain cannot absorb, basically, in the given time. So the machine will be able, or the algorithm will be able to absorb huge amounts of data, and figure out and deduce the patterns that a human wouldn't see, or wouldn't see in a reasonable amount of time. Maybe if you look at the data for 10 years, you figure out the pattern, but that's not practical. And then the deep learning is a subset of machine learning, which we have like the multi-layer. So this is the more complicated form, where we have at a certain limit, the data is not enough. So you keep adding more data and adding more data. And the more data we add, the more the machine learning becomes knowledgeable. And the deep learning, it has multiple layers of learning, if you put it in simple terms. And then finally, today, we have a new subset. Actually, it's a generative AI, or the Gen AI, where the machine learns so much that it can actually start producing output based on all what it learns. It's no longer a very small specific task, but now it's actually very, very knowledgeable of this topic, that it can start creating content for this topic, basically, and generating content based on that. So we will not go to the generative AI in this course, but again, having this mind map, and understanding this distinction is very important. So again, this is the same overview, but in terms of times. As you can see, uh, the artificial intelligence concept, let's have the machine learn or do something, is very old. It's from the 50s. And fun fact, a lot of the algorithms that we use today that empower ChatGPT and other LLMs and other machine learning models are actually that old. They are 50, 60, 70 years old. So why we didn't have this breakthrough in technologies until recently? Like we had basically two breakthroughs, one in like around 2012, you'll see in the next slide, and then the recent one with the ChatGPT a couple of years ago. But still, not even 2 years, if you believe it. So again, machine learning, like artificial intelligence in general, and then with advancement in compute, advancement in amount of data available, we get to machine learning, and then with the, of course, with the internet boom around the 2000 and more data available, we finally got into the deep learning, and then now we are here at the to like 2022, and we are at the Gen AI era. So when we have this, I wouldn't say history class, like the Turing test again, 1950s, the first concept of AI, and some of the boom times, all of this, the real revolution started here. So what did we miss? What did we have here that we didn't have here, right? Why now? This is the main question. And we have a lot of things, if you believe it or not. The first thing, we have powerful algorithms, but still we had algorithms back then. But then these two key factors is what really made this happen. Is the compute power, meaning the availability of complicated hardware like the GPUs, the CPUs, the TPUs, all this hardware that's able to crunch billions and billions of numbers and matrices in no time, that this didn't was not available, or like we barely was making like graphical user interface like the first Mac or the first PC around this time. So we didn't have the compute power, and we didn't have the big data, right? We like there was no internet still. It was not global, so the amount of data we have digitalized, and in a digital form that a computer can read, was was nothing. Like there was barely anything out there. If you compare this to now, it's all the difference in the world, right? Now we have the huge amount of data with the internet. We have the Google projects that digitize everything, every single book. So most of the books written in human history, the whole human species knowledge, is actually digital. So you have every single book in a digital format. You have every single post, all the social media content. We have the social media boom, which we have the user generated content like the Reddit, the Twitter, the Facebook, all of these that the user generate the data and generate the content rather than just a select number of companies. So all these factors contributed to having huge, large amounts of data that's available for these algorithms to read, to crunch, to understand, and to absorb, and be able to learn from, which is the core part. Of course, again with the compute power, with all the hardware. Now, if you don't think this is a big deal, like the idea of having a large amount of data, this cannot be like overstated. This is very, very important. It's like OpenAI, the maker of ChatGPT. It's funny that the challenge they are facing now is they are running out of data. The ChatGPT read everything that was ever written, like read the whole internet. Like the largest open data set now is at 44 petabyte of data, um, just text, for 15 trillion tokens. Every token, like let's assume every word is a token. 15 trillion, not 15 billion, 15 trillion token. And this is open source. This is what everybody has, not OpenAI or Google. So the amount of data that these models crunch, like comprehend, read, and then be able to understand and figure out from, and this is especially for the Gen AI, but still applicable to the machine learning, is huge. It's very important. This slide actually is a fun slide that really shows how much data we have. This is from 2017, and this is from 2020. This is just for comparison. This is the amount of data that gets generated every minute, every 1 minute. And if you read some of the numbers, you wouldn't like even understand this. Like from YouTube or Twitter. If you look at, let's look at Instagram. We have like 46,000 photos every minute, and this is 2017. If you look at Instagram again in 2022, we are talking 34, like 340,000 stories or user posts every single minute, not in a day, not an hour even. So I'm not sure if you are able to comprehend the amount of data we generate every day, 1 day, let alone like weeks and months. So the like this explosion of information, this explosion of data really allowed for the machine learning boom and the recent Gen AI boom as well. Uh, when it comes like thank you Safa for the question. We really, that was my next slide touching on that. Okay, Rami, we understand this. Like, thank you. We really know there's huge amount of data, there's huge amount of compute power. Now what? Like, how does this apply to the petroleum industry? How does it impact the oil and the gas industry? And this is where this course comes in, right? We have all of this knowledge, this very general knowledge, and general data available, but how can we apply this to the oil and gas industry? How do we understand what's going on in the oil and gas industry, and how can we utilize this, learn from this, being ahead of the curve? Like Safa's question is specific to the computing impact, but it's the same concept, like the big data and the computing impact, like the increase in compute power, the increase in the amount of data. All of this gives us the opportunity for much more powerful machine learning algorithm, and even traditional models. Like now you can, with the current compute power capacity, you can have much more complicated like seismic processing, 4D seismic processing, 3D reservoir modeling and simulations running in much shorter amount, like shorter times, or running at a higher resolution, or finishing in faster times, so we can have multiple runs or a larger number of runs. So all of this is becoming possible with the advance in computing power and computing available amount of data. So we will go through every one of these, like a little bit explain what this can be used to. But I would like to stop for a minute. If you have any questions so far, please post them in the chat, and then we can continue. I'll try to read the Dava question. I hope I get your name correct. In my thesis recently, I'm doing evaluation economics, well performance, and well intervention program using VPA macro. My mentor and my lecturer suggest me using SQL, as I have already made a basic code in VPA. Is it common in oil and gas industry using SQL as based on machine learning data processing? So actually, this really depends on what you have. What is the type of data? I'm not really sure I understand the amount of data and the nature of the data. What parameters you have, what attributes you have, as we will learn. But to be specific to your question, SQL is definitely the way to go if you have a lot of data. So SQL is a language that helps you extract specific data from a large data set. So you have a database with a huge amount of data, with large amount of data. So you would use SQL to extract the specific information that you need for your use case. So they are not apple to apple. Like we wouldn't compare VPA directly to SQL. They are two different things actually. The VBA is like to execute commands inside a Microsoft Office application, specifically Excel or Access or even Word. where SQL is used to actually extract information from large data sets. So learn SQL, and definitely if you are already having a VBA macros and you're already utilizing the power of programming inside a Microsoft Office application, definitely keep doing this as well. Um, uh, LB or IB, I'm not sure if I get the like the name correct, sorry. How can we utilize ML to post production of reservoirs? I'm not sure if you mean boost, like BOOST, like improve production of reservoirs. And if that's like, I assume that's what you meant, that the way like we'll go do some, like our challenge today or in this course will actually about utilizing production. So the short answer is we will, the more data we have, the better we will able to understand the reservoir performance, and then be able to extract the bottlenecks or what's holding back our reservoir model, our holding back our production, and then improve from there. uh, a guide on application of ML to seismic interpretation, petrophysical evaluation, and seismic inversion. Um, Okay. Unfortunately, this course will not be seismic because I'm a petroleum engineer by training, not a petrophysicist. I'm not sure. I think Dr. Al Garihi, I think there is another training sessions will be ML in the seismic, if I remember correctly. But again, what we are trying to do here is actually acquiring the general knowledge. You acquire the base knowledge, the technical skills, and the understanding, which is the most important factor to all of this. Like you properly understand how machine learning works, what you need to be able to capture data. So this will be this is the important part that you can utilize. Alrighty. Let's um, I'll just have a sip of water and then we can continue. Not sure if we have one more question. Is the data for ML needs to be provided by companies working in the oil and gas? That's a very good question, Amir. And this is where the challenges come from. These kind of challenges that I'll explain to you today is you have the data. Like the companies, they sponsor these challenges, they put the data out there. You just have to download the data and keep working with it. And this is why I feel this is very valuable. And this is what we'll try to learn to do during this course. Another question, is it possible to use ML for pipping stress analysis? If yes, how? I don't have a specific use case, but let me take this to have it as a note, and I'll try to bring some examples for the next session if I can find any use cases for this. But Ahmedo, thank you for your questions. Uh, do you mean that coding is not important for machine learning studies? Coding is important, that's for sure. It's not a blocker. You don't say I wanna wait for a year or two, be perfect in coding, and then start the machine learning. Do not do that. Start with the machine learning, even if your coding skills are very, 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 very weak, and improve. And this is what we're trying to do in this cycle. Like we will get into this challenge together with no coding knowledge. We'll assume we don't know anything. This is what I will be doing with you. I'll assume that I know nothing. I will be just searching Google, asking a ChatGPT live. It's I know like it might be weird to you, but this is actually my intention from this course, is to break this barrier. Like I want to wait until I know this or that to do machine learning. I want to wait until I'm good at coding. I want to wait. The message from this course, and this is the core message: do not wait. Start with what you have. Start with what you know. I'll give you some tools to help you do exactly that. Just start, and then this will open up doors for you. Um, can ML be used by regulation authorities to aid in regulation the oil and gas industries in their countries? Has it been done like somewhere in the world? It can definitely be done, especially with I would say like the generative AI more than the machine learning in general, because the idea of taking a specific text, let's say regulations from like country X, or even here in the States from Louisiana to Texas, so they have different regulations. A generative model or a large language model, an LLM, can take some of the inputs from one state, revisit these regulations based on the state rules, and rewrite them. The same goes for like for policies. This is really a very good use case. Actually, this is a type of use case that you would love to use machine learning for, or specifically a generative AI for. Has it been used or not? I don't have answer to that. I took another note. I will try to see if there is some cases. To be honest, even if they used ML, they wouldn't disclose that at this point. We still have this stigma. If you use the machine learning or if you use ChatGPT, you are cheating. And this is changing, and this is needs to be changed. It's exactly what happened, I'm not sure, like 20 years ago, that if you have a calculator, you are cheating. And then it became normal, and everybody has a calculator in the exam. This is happening again with machine learning. Like, still, the public opinion is not really settled. We still lack regulations, we still lack policies around them, but we will get there. That you would say, yes, I used ML in this work, but still my work, still it's an original work. So this is a work in progress. Another couple of questions here before we continue. The predictive maintenance ML does, is it done using vibration analysis? There are multiple ways. It's again, it depends on the type of data you have. I did work personally on a preventive maintenance project, and it didn't have actually vibration analysis. What it had, it was for compression gases, and what we had was the pressures of of the turbines, temperatures of them, pipeline pressure, multiple other variables. And after a lot of analysis, we were able to get very good prediction, and a prediction model just relying on the temperature and pressure, even though they are correlated. But the flow rate with the pressure and temperature between multiple turbines was able to predict a general failure, not a specific failure to a specific unit, but a general failure. And this was like with a very little actually analysis, like, and we're actually planning a phase two of a project to really dive deeper into more data. What if there is not enough data? Can we use ML to build for more data? Very good question, and the answer is yes, but it's tricky. Like, you have to really understand the data. What we call this data augmentation. The idea is that, yeah, I have 50 data points, but I need 250. So based on these 50, I can predict a little bit more of data, and I can change a little bit of these data, add noise to this data, because I know the data that I'm getting from my sensor is not perfect. It already has some problems. So the answer is yes, but it's tricky. The more ground truth data means data that I am positive it's correct, it's from the field, it's real data. This is usually the best data to work with, but you can augment the data to increase it, of course, to a certain extent. How do we know the right data we can use for machine learning? You try, basically. This is and this is actually the fun of it. Like, there is no specific answer, or there is no specific data set that, yeah, if I have this data, I can do this. No, like, you would be really surprised, and this is the core of machine learning that I was just explaining, that the code or the algorithm is able to extract relationship, extract information that we didn't see, that we didn't think exist. So with the naked eye, you would say, yeah, how can the pressure and temperature reading predict that the pump will fail, right? Maybe, like, if it's working at normal, you have to have like advanced thing like vibration analysis or something. But no, there is hidden information embedded in the data that we don't see, that a machine learning model can see. This is the beauty of it. So don't prejudge that I don't have good data for this, I will not do this. No, whatever data you have, you start to try. Maybe you fail, maybe you succeed, maybe you have a success to a certain extent, but it's all good output. Maybe you realize what data I need, right? So don't prejudge the data that you have as being the right or wrong data for a specific model. Whatever you have, try to play with it, try to model it, and see how far you can go. Um, if they are using techniques to tweak policies, how can we conclude that the machine is correct on most cases? We are just relying on the machine to get insights, but how can we know that the insights it's giving us is correct? This is the correctness challenge for this is specifically for MML, so it doesn't really apply to this course. But for the LLMs, for the large language models, the idea of correctness is actually doable. It's through what we call like power prompting. So you ask the like the model to whatever information it has to go back and to check this piece of information and make sure it can correlate to a specific source. And this is what Bing now, if you use Copilot with Microsoft Bing search, for every statement, if you hover on it, it will give you this statement is from this specific source. Of course, to a certain extent, it's a challenge, and this is like the topmost challenge, especially if you are following the news. We had the Google overviews, which using AI, and then it starts to give wrong information, asking people to eat rocks and put glue on the pizza, and Google is fighting that. So this is a really like ahead of the curve and like bleeding edge challenge, but it is doable. And there is some legal cases. I was just reading an article yesterday about the legal solutions, because in the legal field, if you have like you go in front of a judge, you cannot give fake information, and they solved out the solution in the legal field. So it is a challenging, but it is doable, and it keeps improving every single day. Are there specific sites to extract real oil and gas field data? This is what we'll explore. We'll have a couple of websites which has some um, oil and gas data for the challenges, but also we can share some other public sites for all over the world where they share. Usually, you go to the government sites like Norwegian, here in the States, in Canada. A lot of these governments actually they share public data, public oil and gas data, production data, well logs data. So you can go and collect some of this data for yourselves. But again, my recommendation, and this is the approach for this course, is to actually start with the challenges, and we'll explain what this means in a bit. Um, Couple more questions again. How do we know the right data we can use? We answered this. As you mentioned, development of AI has been increased since 2012. Before that, how could the huge petroleum company succeed? So when it comes to oil and gas, and still till today, we still rely on what we call analytical models, like equations. You have it's mathematical models, it's physics-based models, and now this is what the industry is exploring. That because physics-based model, you solve the equations, you solve the partial differential equations. For my masters, I was solving like fractional partial differential equations. I had to write a program, a whole reservoir simulator to implement these equations and solve them into my reservoir simulator. So it's a lot of work and it takes a lot of time, and it's on a very small scale. So the industry now is exploring the data-driven modeling. It doesn't really care about the physics that much. Like the degree to which you should rely on the physics is what being discussed. Like do you right now you are going 100% physics and the mathematical equations that we solve, and going all the way data without like respecting the physics also has some problems. So we're trying to have this middle ground where we are data driven, but we're still constrained by the physical model itself. So this is the approach that the industry is trying to go through. If you are using ML technique to quick policies or get insights, conclude the insights, I think we answered this. We depend on trial and error technique until we reach the closest answer. That's exactly it, Safa. This is 100% what is machine learning. It's exactly how we learned everything. The whole machine learning is successful because it's trying to mimic the human brain, like the most sophisticated, the most advanced um, thing that we know is the human brain. This is still the mystery to us, even with all the technology we have. And this is the concept of the neuron. Like that's why it's called neural network, because it's based on the brain neural idea. And when it comes to the actual learning of the machine, it's the human feedback, the same reinforcement that we do. What reinforcement very quickly is that you do something and then you get told is it right or wrong. If you go back to your like childhood, this is what we learned, a lot of stuff. Like this is like I'm trying to memorize the ABCs, right? This is a B, and the next time, oh, this is a D. No, it's a B. Okay, it's a B. And the next time it's a D. No, it's a B. And the third time, yeah, it's a B. Yeah, it's a B. Right? So I guess something, and then I have a tutor, I have my parents, they tell me, yeah, that's correct, and that's not. And I do it again, and I do it again, and I do it again until I really know this is a B for a fact. Because I tried multiple times to guess it, and sometimes I got it wrong until I really know it correctly. So it's exactly that, and we will see this through code. Like we'll try to do this hands on. How could you think that machine learning can be applied to improve exploration and production? And again, this is very generic. The best idea to think about it is what specific problem or what specific challenge do I have, and how can machine learning help me? This is the best way to think about it. Like for exploration, what kind of exploration are we doing? Is it like magnetic resonance or magnetic seismic or whatever problem we have, and then the challenge we are facing is that it takes us 3 months to analyze the data or process the data. Can machine learning help us in this specific task, like make the data processing maybe faster or more efficient? That's one way of looking at it. The same, like, so improve production and exploration is very broad, and we will have some examples here. But the idea is that if you narrow down a specific problem or revisit anything that you do and ask yourself, can machine learning model help me in this would be much more effective. What steps can be taken as a beginner machine learning to become proficient in it and using it in for petroleum engineering applications, and what projects can we work on to build these skills? This is this course. So in this course, we'll have one example, one approach. Again, it's my approach, which is like move fast and break things, and it's also called learning while doing. It's some people like really love it, some people it's hard for them to adopt, but this is what I think is the fastest way to become proficient and to gain skills, and we will try to do this together in this course, but again, if you don't love that, like if you think this is not the way I love to learn, I really am a books person. Give me a couple of books, I will read through them 100%, and then I will start working. If this work for you, that's fine. But the whole idea is that to start acting on it. Don't wait until to finish 10 books. Don't wait until you get a PhD. Don't wait. This would be my core advice. What do you think about using machine learning to increase or decrease wellhead choke on gas well by automatically? Is there a new technology being used? Again, I'm taking these as notes, and I will maybe every session before we actually dive deeper into our hands-on session, we can have some case studies for these specific questions. So I have the stress analysis. We have like choke. I'm not sure because on top of my head I cannot really name specific case use cases. So I will try to bring use cases for these points that you bring up. So thank you for your input. What do you think about using machine learning? Yeah, we got the same question. Uh, do you have YouTube channel where you have other lectures? I don't actually. I'm not that famous. But yeah, thank you, Dr. Elgarhi, for giving me the opportunity and this platform to really try to add any value. All right, yeah, let's get back to the slides. That was very good questions break. Let me get my sip of water. All right. So ML can be applied in various ways. I think we discussed a lot of that while we had the QA break, but let's revisit them very quickly. Predictive maintenance, again, can be used to analyze equipment sensor data. Again, which sensors? Uh, it doesn't have to be vibration data. It doesn't have to be. We don't know. Whatever data we have, just get them and see what we can get out of them. In parallel, and this is important. The more data, the better, right? So in parallel, what I would do if I had this case, I'm working in a factory, I would start reading papers about people who did predictive maintenance or failure analysis into similar situation or similar setup or similar equipment. And then I will have this comparison, right? Oh, so they had this amount of data or they had this sensor data. Was it very important? How much did it improve their model? If we remove this data, which I don't have, is the model still useful? So I evaluate my data on my own, and then I also read other case studies and see what data they have, how did they utilize it, and how can we improve it. Reservoir modeling we already discussed, like the accurate models. Of course, from reserve estimates to optimization to everything that's about reservoir modeling, and trying to have what we call data-driven models versus the physics-based model. Again, till now we still rely on the physical models. There is a lot of pushback on the data-driven models, and it seems the industry will converge on the combination. Like you have a data-driven model which is constrained by the physics, so it doesn't actually solve the actual physical, but whatever solutions you have, they have to validate the physical requirements. I believe this is where we are going, and this is where we will have the most potential. The seismic data analysis, again, from identifying potential locations to improve accuracy of exploration and so on, a lot in the seismic, especially with the seismic being huge data in gigabytes or terabytes sometimes. So a lot of efforts, a lot of active efforts in the seismic data analysis domain. Any process optimization, and this is again for everything that you do. Think can I use an ML to really help me with what I'm doing? I'm having a well planning. Um, uh, what variables goes into a well plan? Can this be fit into a model? Can I quantify this? Thinking from a machine learning perspective is important. Predictive analytics, any trends or any outcomes, and actually our challenge that we will be discussing is actually can be classified in this domain. Like we want to be able to predict uh, the bottom hole pressure, basically, as we will see. Quality control, again, can be like ML can help us in any detecting any anomalies. This is something the machine learning is very good at, right? Because again, it's all about trends. So if you have a specific trend or expected trend, let it be in production in a specific machine in a specific factory, whatever, having anomalies, this could be detected. So anything that you think has a specific trend, and you want to know if you are deviating from this trend, like think of applying an ML model to that. Supply chain optimization in general, and of course the HSE, like the safety. prevent incidents or minimize environmental impact. This usually typically would be by analyzing the sources of these hazards in your environment, and then collecting much data about these different incidents. Again, it's about data. This is what you'll find us going back to, and this is what differentiates a company really utilizing machine learning or a country or a nation utilizing machine learning versus one is amount of data available in a digital format, in a structured format. Structured data is the hot keyword here, and this is important to be understood and to be utilized. If you don't have this data, and this is, as we discussed, this is the whole reason for this boom, that we have more and more data and more computing power to really like digest this data. So if you have a paper, like a couple of paper sheet files, and you come like, I want to do machine learning, I'm sorry, I cannot help you, right? So this is the same here. So how specifically can machine learning help me in this domain? The question comes back to you: what data you have about this? Do you really have very detailed reports about your incidents, what happened, when it happened, why it happened? If you have 1,000 or 100 incidents, we can take these reports, digitize them, convert them into tokenized models, and then try to see a pattern. Yeah, so it seems like the incidents always happen after this. Like, we always have a problem after, like, 2 weeks after we do the maintenance, right? Nobody noticed that. Nobody saw this pattern, but the machine learning was able to see the pattern, right? If it has detailed information, detailed data. So the more data we have, the more structured data we have, the better conclusions we can derive using the models. Alrighty. So the million dollar question, right? Where can I start? And again, my advice is very straightforward, very specific. Get your hands dirty, meaning like don't go play in the mud. Meaning, like actually start doing, start typing, start exploring. This is the most important. This is the barrier that I'm trying to break with you in this course. Like, you really have the confidence to actually start you doing machine learning, basically, with like, I don't have data, I don't have coding skills, I don't have anything. Let's still do it. And this is the barrier that I'm trying to break um, using this course. That, like, don't let anything hold you back. Okay. And again, repeating coding is no longer the challenge. Don't wait to be a good coder. So two platforms that I suggest we start with. We will be using Onward. There is a specific ongoing challenge on Onward that we will be um, working on, basically. And there is always Kaggle. So what are these platforms? These platforms are awards oriented challenge platforms. You get, and we will explore them live now. After I just have a couple more slides, and then we will go like demo hands on. Again, like, I don't, this all the slides I have. The rest is really practical and hands on. So these two platforms, they have what they call challenge oriented. So they give you data. So they have a lot of the data sets. They get the data from different sources. They clean it to a certain extent, of course, and they prepare it for you to start working. And then we have the community associated. So you find other people's solution. You see the code from other people. You ask people questions, and this is the real value here, that you really learn from. You have the opportunity to participate in the challenge and win a prize if you're really able to succeed. But for your beginning, like, don't worry about winning. I don't win this challenge. They need a lot of time dedication that I don't have, but I learn from them, and this is the core, right? I go there, I explore the data set, I try to participate, and then when the challenge is over, and sometimes they share the winning code. This is really the value, like, to really see, okay, this is how I thought about the data. This is how I thought about my model. Oh, they did something different. Oh, I didn't think of that. I didn't see that. That's very valuable. That's and then I learn from this and I can apply this to my next challenge or to my next project basically. So this is what I call a 100% hands-on approach. It's learning by doing. You are really no books, like I'm not sharing any books with you, I'm not sharing any slides. It's just dive there, just go there, sign up, create an account. It's all free, and start playing. Now, of course, you need some guidance to get started, and this is what I'm trying to do here to get you started and hopefully guide you a little bit or give you an idea of what you can be doing or how to approach this. So I will just like for the last couple of slides, I will these are some definitions that I would love to for we to be aware of, which we'll come back to later. But these are just a typical step, like typical steps in any challenge. So we will go through these um, quickly before we actually jump into the actual websites. Any questions before we continue? Give you a second and then we continue. Okay. So um, when it comes to a challenge, like I have a specific challenge, what I would have is the most important that I need to look at is a problem definition. What are we trying to do here? This is the core. When I have a challenge, I want to know what we need to achieve. If I don't have a specific goal, if I don't want to achieve anything specific, then I'm wasting my time basically, right? So the problem definition is what really drives uh, uh, drive the whole thing, right? So it's what you want to predict. For example, you want to predict future oil production, right, from historical data. If you want to predict price of the oil or detect any anomalies in your production, so this indicates something is going wrong, or classify different types of wells. Like, so these wells, I have specific wells. They seem to be in different production zone or different uh, reservoirs, but I don't know what's going on. Which wells are should be grouped together and dealt with a specific treatment. So the classification is one of the way that a machine learning, and we will talk about these different types of machine learning models and how we deal with them. So this is the first step. The second step is the data. Again, it's always back to the data. Um, when it comes to the data, we need to gather data from different various sources, of course. Like we cannot just rely on one source. The more sources we have, the better. And in the oil and gas, this includes like sensors, production logs, so geological surveys, any kind of data we have. And then we need to clean it. And this is actually a part. So our work will start from here. So we'll have the problem definition given to us. We will have the data given to us. And then our work starts from here. This is where we start to clean the data. Because this is coming from real life, or like, don't assume the sensor that's in the well buried thousands of feet with extreme temperatures and the pressures. Don't expect this sensor to give you very accurate, precise data. No, this data will have deviations. This data will have errors, will have problems. So it's important to be aware of that. So you need to clean this data, handle any missing data, remove any inconsistencies or outliers. So you, like as we said, the more data the better, but the more good data is the better. So a crucial step in our work is to actually clean this data and get rid of any data that we believe is not helpful or like not clean enough. And then what we call engineer features, or features engineering. This is the hardest part ever. This is what takes. This is some people say this is 80% of the job. Um, um, Could you share PDF? Yeah, I think like I don't have a lot of slides, but definitely we can share this slides. I will see with Mayar and Dr. Gahi. So having this feature engineering is very crucial. It's what me like it means. How can this data be in its best format that the model can understand it? Do I need to normalize it? Will understand what normalization is? Do I need to normalize it? Do I need to convert it to another format? Do I need to change anything about it? And there is a lot of things that could be changed. Believe me, um, to change it in a way that the model can understand it. So a lot of work goes into feature engineering, and this is something you can never say, "Yeah, I'm now I know all about like feature engineering." This is an ongoing process, and that's why I don't recommend you wait for some time to start, because you need a lot of knowledge actually to actually say I'm an expert, but don't wait to get this knowledge. Like as you go, you will learn and your skills will improve. But at every stage, you can have some output, you can have some value. So take this value and don't wait. The EDA or exploratory data analysis, this is very important, and this helps you with the feature engineering to really understand this data. I want to visualize this data. What is the data distribution? Is this data balanced? Does it have a correlation? Does it have a problem that I need to fix? So a lot of work again goes into understanding the data you are dealing with, and understanding the different variables that you have or attributes. And then comes the model selection. This needs a little bit more knowledge, but now with the machine learning models like the LLMs, the chat um, bots, basically they help you a lot with that. Like, do I have a regression problem? Do I have a classification problem, clustering problem? We will try to identify these types. Like, we will dive a little bit deeper when we get to this step in our challenge. But for now, it's just what machine learning model or algorithm that we need to do. Like, as you can see here, it says the right algorithm, because again, all of these are just algorithms, right? So for every problem and for every data set, you have to choose the right algorithm for your problem, and this is what we'll try to do. And then we have the training and evaluation. So this is I think back to, I think Safa was saying, is it a trial and error? And when I said yes, this is here. You really train the model. You give the model, okay, here is the data, try to learn something from it, right? So, and then the evaluation is some data that the model doesn't see, and you keep it for yourself, and you test the model. Did you really learn? So I show you, like, I'm teaching you how to do addition, for example. So I tell you 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 4 is 5, and so on. And then I ask you, what's 10 plus 11? So I didn't teach you that, right? I didn't teach you, but now I expect you to be able to figure this out on your own, because you have been trained a lot, you have learned a lot. So I ask you, what's 10 plus 1? And you say 12. I say wrong, and I give you more data. I still don't tell you that 11 plus 1, 10 plus 1 is 11. I don't tell you that, but I keep showing you other data. And I ask you again and ask you again, until, without explicitly telling you that 10 plus 1 is 11, but showing you so many other addition operations, you tell me, yeah, 10 plus 1 is 11. So okay, now you learned that. So you learn this on your own by basically try and error. So this is what we call training and evaluation. So the training is the data that I give you, we call ground truth, or like, I tell you what's 1 plus 2, what's 2 plus 3, and so on, but I don't tell you what's 10 plus 1. 10 plus 1 is my evaluation, how I evaluate you. So I cannot evaluate you on something that I already taught you. This is like, okay, you just memorized it. And this is something we call overfitting. It's basically the model memorizing what you're telling him. I don't want that. I don't want the model to just memorize. And this is back in school. This is exactly what they try to fight. Don't memorize the book. Understand the concept. And this is exactly, again, a lot of similarities between how we learn and how we're trying to make the machine learn, basically. So we when it comes to evaluation, we ask the model about data that we didn't show it to him. We didn't explicitly tell him what this is. So, but where do I get this data from? That's why we split the data. If I have 100 data points, I don't give all the 100 data points to the machine to learn on them. No, I give it 90 and I keep 10% or 10 data points for myself. And these 10 data points is how I test the model if he really learned or not. Because if I give the model all the 100 data points, then I don't have any more data to test or evaluate the model. So this is a very important concept. And you see how complicated this sounds, like how very deep. In coding, it's just one line. Just one line. You do all of that. You split the data. This is the training. This is the testing. Like, so that's why the concept to understand what trailing and evaluation means is much more important than just memorizing how to type the code to do that, the data splitting or the training and evaluation. And then we train the model, of course, like the model start to learn, and then we evaluate. How good did the model learn? Is it like we have like absolute mean error, we have root square error, we have the accuracy, the precision, recall, F1 score, all of these are different matrices that we use to evaluate the model, and they don't work for each algorithm. So based on the problem type and based on the algorithm that you use, which in turn is based on the problem type, right? So your model, your algorithm is based on the problem. And the same way your evaluation is based on your problem and based on the algorithm that you use. You cannot evaluate all the models the same way. The same idea. You cannot evaluate a 2 years old, a 5 years old, and a 20 years old people with the same way, right? Everyone he learned in a different way, so you should evaluate him in a different way. And this is exactly true for algorithms again, based on the problem you have, based on what algorithm you chose. You have to also choose how you will be evaluating this model. Like then we have the model tuning, what we our fine tuning. Like the model is working fine, but we can really improve it. We can tweak it a little bit to improve its performance. What we call hyperparameter tuning, and there's cross validation to ensure that the model generalizes, meaning the model didn't just memorize what I gave it. No, it actually understood the real relationships between the different attributes and really extracts the information properly. Last but not least, the deployment, right? How I will be using this model. Again, it can be like I can deploy it on a server, or I can just use it at home. Like I can just use it on my machine. But if I need a lot of people using it, then I need it to be deployed somewhere in the cloud, on a Google server or an Amazon server. So I don't think we'll be discussing this, but it's the natural step into this, and that's it. Actually, that's all like the typical steps in a challenge. And we can, of course, we will not get to actually work with a challenge today, but at least I want to introduce you to the challenge, show you the different websites, Kaggle and Onward, and then next session we can answer some of your questions or have a little bit of theory at the beginning and then dive into the hands-on. So any questions before we get into the demos or show the website? Like I give you a couple of minutes to if you wanna type any questions until I share the proper screens that I wanna share with you. Please type your questions. Uh, Now is a good time. Yeah, I don't see any questions, so let's continue. I see questions, but I think I didn't read them. Uh,
Dr. Rami, after we end the session, we will have a quick Q&A session. We have 17 questions.
yeah, but I was going through them
Oh,
live as
you would
I
like, you want to answer them now?
I answered most of them. We just have like three here new. So I had a couple of stops and we did answer some of the questions. So now just have three new ones. Like 14 have been already
Okay,
answered.
okay,
I changed the strategy a little bit to be like
okay.
interactive. Yeah.
That's very
So
nice.
yeah, I feel like again I was just telling them like I was expecting like a more interactive. So this is how I drive, but they have been very great in posting the questions, so it has been going well. Answer these three questions and then share my screen again for the last part of the class today. I know we are about to run out of time. Alrighty. So how can we understand what model to choose or what method to use after we had done exploratory data analysis? That's very good question. The short answer is it's about the problem definition. What are you trying to do? Like again, the big categories, is it a classification? Is it a regression? Is it um, any anomaly detection, whatever type of problem. Every problem has a typical set of models. Actually, for our challenge, we have a completely different thing. We'll be using like time series challenges. But again, your problem definition and what data you have is a big part of deciding this. And again, this is the part that really had some like you need to learn it, but with the ChatGPT and with the recent LLMs, they will answer you very quickly. Like it's much easier job now with the presence of other tools like ChatGPT and Google Gemini. Could you mention website links here? Sure. Here's the first one. I'm not sure. Do you see the links here? Because this is to panelists, I think. Yeah, to attendees. Uh, I'm not sure if my chat goes to you. Anyway, like we will share the PDF and it will be with the PDF. I don't think you see my chat for some reason. But we will open them together now. Um, and then finally, the last question: a case of having good training results but reduced test data performance, say in terms of R2 value, what could be the issue? This is typically a case for what we call overfitting. So an overfitting is that the training really memorized your data, right? So I ask you what's one plus two, one, two, like every single one that I showed you, you really memorize it. But then when I ask you something new, you don't know. So that means you did not learn how to do addition. You just memorized all the examples that I showed you, and this is very crucial. So that's very important distinction. That it's not about really memorizing. So and again, how to this is again identifying the problem that it's an overfitting problem. Now, how do we identify and how to solve the overfitting? That's a different story, right? And again, there is a lot of tools. How you perform the model. There is something called early stopping. Like there is a lot of techniques that we can use to combat that. But at least you need to understand that your model has overfitting, and now I want to solve that. We only have 10 minutes, so let me at least quickly show you the websites. I'm not sure if you got the links or not again. Now we still have a couple of questions. Will it help machine learning? Okay, so having good training results. Yeah, we answered that. Okay, let's go to the websites. So the website that I want to share with you here, as you can see, or still, I think now you can see, is Kaggle, your machine learning and data science community. So the whole idea here is that learners here, developers here, and researchers, and you have when you have a big project, you get all the community, all the people working. You have all the data sets as we discussed. Where do you get the data from? Kaggle has, as they say, 339,000 high quality public data sets. So everything from avocado prices to video game sales. So this is very, very valuable, and we will see some examples. And then the notebooks. This is this 1 million public notebooks. These are like very smart people, much smarter than me at least, and they have their codes available for free. How they solve the problem, all the code. I'm to very, and this is most of the time these are winning codes. So this is the code that win the competition, or this is the code that best solve the problem. So that's where I'm telling you, like, it's not about the actual code, because the code is there. You will find it from published for free, as you can see here, or you will have ChatGPT write a lot of the code for you. But really, how to think about the problem, understanding the problem, and how to approach the problem is really the value. If I go here and I write like Kaggle oil and gas, you think I did this search before here, and you can see, yeah, you see here is very open data sets, oil and gas production data. So you already have this is 6 years ago. This is pretty old. This is 3 years ago. So this is data set ready for you to download, to start to play with. Production date, country, town, field. This is another one. This is global data set for oil and natural gas production, prices, exports, and the net exports, right? So huge amounts of data available, and then you can go and explore what notebooks or what models did people download and use this data for. So this is one of the very like valuable sources that we talked about, that you should utilize in actually having and looking at the data. So this is Kaggle. We will not be utilizing Kaggle in this course, but what we'll be using is Think Onward. It's an innovation platform. They are doing multiple stuff, but the core thing that they do is actually their platform, the challenges on the platform. So I think the platform is, you have to register, but it's free. So please sign up, and you can see all the challenges that like the active challenges. Now they have two challenges that are active. This is the one that we will be using actually for this course. At least this is my plan. Is spot the trend, pattern recognition in 1D pressure data. This is oil and gas production data actually. And we need to find the pattern of this data. Again, this has been going for 10 weeks. It only has 3 weeks left, actually. So we will maybe during the course we will try to at least submit something. I don't think we might win, to be honest, but at least we get to submit something and understand how to see the challenge. You can see the upcoming challenge. There is a seismic challenge. I know a lot of people asked about seismic. The prize will be 40K, so that's intriguing. Again, don't like a lot of professionals here, so but it's not impossible. Like a lot of first timers actually won, but you will learn a ton. So this is my message to you basically from this course, is to open your eyes on this kind of challenges, this kind of opportunities, and encourage you to go explore them, participate, and learn while doing them. So this is our challenge. Again, they are texting me that we are at time, so we will really go through it next week. This is, I think, for your petroleum engineers, yeah, like you can recognize this as like measured and calculated bottom hole pressures. This is the data they will give us. The how can we evaluate the model? This is a little bit on, I would say, on the advanced level. So we can, like, I'll try to slow down a little bit. We might have some uh, like, you don't have to really care about the exact code, but the concept, these steps like that we mentioned, how to do feature engineering, how to select the model, I want to give you an example of how to do this, how to participate in such a thing. Just have any submission available, even if you can already see people are jumping at the top. So it's very very good and a challenging community to be a part of. So trying to make a submission in this challenge is my original plan for the course. Again, your feedback, if you think this is too advanced, like we really need to slow down or go to a little like more basics, I'm happy to do that. But my original plan was to live with you try to have a submission in this competition. So this will teach us a lot of things, how to get the data, understand the data, how to run a basic machine learning model. The good news here, that I know this sounds very scary, but they actually give you the code that will get you 70%. So already you see people are getting lower than 70%, but the code they are giving you ready should give you 70% if you just know how to run it. You see, the code is already written for us. And this is my plan, to really just go through this code, understand it, and go through the steps, and do a submission for this competition. So again, you can see the code is not always the challenge. A lot of the times you have the code ready, or you can use LLM or ChatGPT or whatever to type the code for you. So it's 2:20. I need to wrap things up here. Again, thank you so much for your time, for attending. I know this might have been too much, or I wasn't sure of what are the expectations. Usually, I collect the audience expectations at the beginning, but this setup is a little bit different. So I hope you learn something today and learn something in the future sessions. A last question: can we start at beginning level and work on a small project and really see the result working? That's 100% correct, and especially if you go to like Kaggle, they really tell you the level of the competition, how hard and how easy. Some of them like don't have any prizes, or like very very low. You don't have to start with $1 million prize. Let me tell you, I usually go for the already knowledge one. There is no prize because people share knowledge there. This is a very famous one, that like Titanic machine learning. Uh, just from some data predict if who will die on a Titanic ship. Very interesting problem. You always have the answers. Like you can go to the notebooks, and you can see people already have the code. This code is the best code. Like it's submitted 2 years ago. People voting for the code, so you really can read the code, understand it, execute it. 100% ready for you with zero knowledge. But this is a course. Like you are learning from here, and this is the core that I want to share with you. Like you can reach this. Um, you can reach this knowledge without really go pay $1,000 for a course. This is out there. This is free. I'm bringing this to your attention, and this is my main message from this course.
Thank you. Thank you so much, Dr. Rami, for this informative session and for your time and effort as well. We really benefit quite from it. Thank you so much. Thank you so much again.
Thank you. Thank you, everyone. Sorry if I passed the time. Best of luck for the whole internship. And thank you, Mayar and Dr. Garhi, for your amazing work organizing this. Have a great
Thank
one.
you.
Bye bye.